Okay, now I want to take that a little bit further because we've calculated the 95% confidence interval, so hence calculate the margin of error for the 95% confidence interval and determine the sample size to achieve a margin of error of 3%. So this is two problems built into one. Now, I set up here that the margin of error is given by this rule just here. So that's the 1.96 times the standard deviation, which luckily for us was actually in our calculation, which we did right here. So what I'm going to sort of say about this is we had 0.6 plus the margin of error, and we ended up with 0.6784. So because of that, I should straight away be able to say that m is equal to 0.0784. And I could have done the calculation to figure that out, but I think that it's a fairly easy observation to make there. And now that I have that margin of error, well, this means 7.84%. Okay, I want to know what the sample size has to be to achieve a margin of error of 3%. So for the second part of the calculation, I'm going to let m equal 0.03. And then I'll just work it out. So 0.03 equals 1.96 times the square root of 0.6 times 0.4 divided by n. And I don't know what n is in this case. That's what I'm trying to find out. We need to rearrange that, but what I'm going to do is I'm just going to go to the calculator. And I'm going to write 0.03 equals, I'm just going to steal that part right there, and I'll change that there to x. And then I'll just highlight that and solve. Equation inequality, solve for the variable x, that's okay. 1024.42. Now, that means that we need to have a sample size of 1024, which is pretty massive, and technically it wouldn't really be 1024 because at that point we won't have achieved the margin of error of just 3%, it'd be a little bit higher than 3%. So I should really say 1025, as that's going to go past that point. So I'll just say right here that n is equal to 1025 people. And that's it really. Now what I will say about this is that we can calculate other confidence intervals. The other common ones would be 90% or 99%. And I should also say that these confidence intervals are quite important in terms of statistical measures, like they're used, well, studied a lot at university in statistics courses, that kind of thing. But also, it's used a lot in medicine, that kind of thing. You know, we want to have a pretty good confidence interval before we go testing out various kinds of drugs and those kinds of things on people. So, anyway, if we were to calculate a 90% confidence interval or a 99% confidence interval, we would actually use the exact same calculation, but there's one thing that needs to change, and that's this value of 1.96. Okay, so these values will change, and let's see what they change to. So if I go interactive to the inverse normal CDF with a tail setting center and a probability of 0.9, so 90%, then the value we would use would be 1.64. And so you would replace that 1.96 with 1.64. If I want to do a 99% confidence interval, then I would go to, again, inverse null CDF, tail setting center, and this time a probability of 0.99. And the answer there is 2.58. So I'll just add this in. So for a 90% confidence interval, we use 1.64. For a 95% confidence interval, we use 1.96, and for a 99% confidence interval, we use 2.58. And that's the three values that you really need to know. Like, I'd suggest just memorizing them, but you know, you could be asked for a different confidence interval. If you are, you just figure it out like I did just then. And this can also be done in the calculator, which, you know, I will go through later on during class time. Anyway, I think that's it. So I'll leave that there and see you next time.